Welcome to the show and tell video for Team Firebot. I'm Lance.
I'm Sean.
I'm Nell.
So we wanted to make a cute robot, and Firebot's inspiration is this 1930s Leyland Cub fire engine. I turned that into a low poly CAD model in Onshape like this. And by the magic of 3D printing, we have this. Now's a good time to point out that this robot has mechanism wheels, which allows it to move sideways. But mechanism wheels only work with good traction on all the wheels, so we've split the front and back chassis sections and connected them with a bolt so they can twist relative to each other and keep all four wheels on the ground. Here's the finished article. You can see the sensor head mounted on the ladder, and you can also see the robot being driven around manually by Sean. The robot is modular and reconfigurable for events. This setup here is for eco-disaster. You can see the grabby arms and the cutaway mid-body for storing barrels. The other major attachment is the Nerf gun. A standard 6-shot Nerf magazine fits in here, and a firing servo pushes the dart into the flywheel, and the dart leaves the gun with just less than 0.5 joules of energy, which is the legal limit for a toy. And this shot shows where the gun mounts on the robot. Team Firebot don't live anywhere near each other, so this is unfortunately the best we can do for now. Over to Sean to talk about the electronics.
Thanks, Lance. So this is the part of the robot that I got stupidly excited about. So instead of buying a motor controller off the shelf, which would be boring, I decided to build one. And I was excited about the idea of building a brushless motor controller, which is quite a challenge, as it turns out. I succeeded in building a brushless motor controller around the Raspberry Pi Pico that can control 4 brushless motors at the same time. I use many features of the Raspberry Pi Pico. We're an I2C peripheral and controller. Peripheral to be controlled by the main Raspberry Pi, and a controller to read a current sensor to monitor the health of the batteries and the motors. I use PIO blocks to read PWM Hall sensors and get the position readings for the motors, which is important for the control algorithm. I use DMA to pull those readings into main memory without needing CPU intervention, and to timestamp the readings as they came in. 12 PWM outputs to output to the motors all at the same time. And then both cores in the Pico are put to use. So CPU 0 is doing the real-time control, and CPU 1 is doing stats and reporting. We made this open source on GitHub, and it's covered in our blogs as well on the Firebot blog. Next slide, please. Here's a little montage of building the controller from the hello world on my bench through various spaghetti wiring phases up to the final article in a little 3D printed chassis that slots into the middle of the robot. Yeah, next slide. The rest of the electronics, well, and the Pico, all go through this custom hat that we built. So we have wiring for the Pico, a servo controller, another power monitor to monitor the second set of batteries, a time of flight sensor to give us position information relative to the front of the robot, the camera, which Nell's going to talk about. We have a screen on there so we get direct feedback on the robot of like voltages and stuff of the batteries. And we have an IMU on there, which allows us to do drive-by-wire with heading hold. So when we say turn 90 degrees to the left, then the robot knows what 90 degrees is. We're not just counting the revolutions of the wheels. We can precisely do it. Also allows us to counterbalance any slippage that we get while we're traveling sideways with the mechanism wheels. And yeah, so Nell's going to talk about the software.
Our software is mostly written in Golang with a Python subprocess for accessing the camera and analyzing the camera image. We use our wheel rotation counts and heading from the IMU to compute pretty accurate dead reckoning, and the camera to identify targets and colors, and to check and adjust our beliefs about the challenge arena and where the bot is within it. For the autonomous challenges, which are really challenging this year, we iterate between rechecking our sensors to update those beliefs and then initiating a bit of movement to wherever we think the next target position is. And that's it. Thank you from Team Firebot.